Welcome to Chapter 8, Correlation, Pearson Test and Spearman Test. This video shows how to process the Pearson and Spearman tests. You can watch the entire video or use the time slider to navigate directly to any time point. Correlation analysis computes the nature of the relationship between two continuous variables. The relationship can be characterized using two parameters, the direction of the correlation and the strength of the correlation. The correlation, represented by the lowercase r, ranges from -1 to +1. The sign, plus or minus, indicates the direction of the correlation. Positive correlations occur when the variables move in the same direction. When x goes up, y goes up. Or when x goes down, y goes down. Negative correlations occur when the variables move in opposite directions. When x goes up, y goes down. Or when x goes down, y goes up. The r value also indicates the strength of the correlation. Values that are nearer to -1 or +1 are stronger than values nearer to 0. For example, an r of 0.25 is here on this continuum. We can refer to this table to label the strength of this correlation. 0.25 is between 0.20 and 0.39. Hence, we would refer to this as a weak positive correlation. A correlation of -0.75 is here on the continuum. -0.75 is between -0.79 and -0.60. Hence, this is a strong negative correlation. In this example, a researcher wants to determine if there's a correlation between how happy a person is at home and how satisfied that person is at work. The researcher gathers two continuous variables. Each participant responds to the home happiness survey, which produces a score between 0 and 30, and a workplace assessment survey, which produces a score from 0 to 100. We can order a scatter plot to visualize the data from these two variables. Each point represents the two values gathered from each individual. Specifically, this point represents two values gathered from one of the participants, who scored 22 on the home happiness survey and 70 on the workplace assessment survey. The regression line, sometimes referred to as the trend line, can be thought of as the average pathway through the points. In this example, the correlation is 0.518408, which will round to 0.52, and the p-value is less than 0.05. If the p-value is less than or equal to 0.05, then we document that there is a statistically significant correlation between the two variables. Otherwise, if the p-value is greater than 0.05, then we document that there is no statistically significant correlation between the two variables. Before running the Pearson correlation, there are three pretest criteria that need to be met. First, the data for each of the two variables should be normally distributed. The second and third criteria, linearity and homoscedasticity, involve observing the scatter plot. If these criteria are all satisfied, then run the Pearson test. Otherwise, run the Spearman test. This example uses the data set ch08_demo. On the R syntax guide, go to page 9. In Packages, check CAR, MV norm test, and psych. To check for normality of both variables, copy this line of code to the console window. Change the file name to ch08demo. Then change continuous variable x to home happiness and press enter. Now press the up arrow and replace home happiness with job satisfaction and press enter. Here we see that both p-values are greater than 0.05, indicating that both variables are normally distributed. Hence, normality is satisfied. To check for linearity and homoscedasticity, we'll inspect the scatter plot. Copy this line of code to the console window, change file name to ch08 demo here, and here. Then change continuous variable y to job satisfaction and change continuous variable x to home happiness and press enter. To check for linearity, we observe that the points follow a fairly straight line. There are no unexpected bends or curves in the distribution of the points. Hence, linearity is satisfied. Finally, we check for homoscedasticity. We observe that most of the points are arranged in an elliptical pattern. Hence, homoscedasticity is satisfied. Since all of the pre-test criteria are satisfied, we'll proceed with the Pearson test. To run the Pearson test, copy this line of code to the console window. Change file name to ch08 demo here, and here. Then change continuous variable x to home happiness, and change continuous variable y to job satisfaction, and press enter. The core is the correlation, also known as the R, which is 0.52. Here we see that the p-value is less than 0.05. We would document that there is a statistically significant, moderately positive correlation between home happiness and job satisfaction. Those who are happy at home tend to be satisfied at work, and vice versa. We could also state that those who are unhappy at home tend to be unsatisfied at work. To determine the number of participants, the n, add 2 to the degrees of freedom. 84 plus 2 tells us that this analysis consists of data from 86 participants. If the pretest criteria were not all satisfied, then the Spearman test would be the appropriate statistic to run. Copy this line of code to the console window, change file name to ch08 demo here, and here. Then change continuous variable x to home happiness, and change continuous variable y to job satisfaction, and press enter. Here we see the Spearman row, which we would round to 0.41. This is the non-parametric equivalent of the Pearson R, the correlation. And here we see the p-value, which is less than 0.05. This concludes this video.